Welcome back, everybody. In this video, we're going to be going over section 1.9, which is on properties of real numbers. So at first, one thing to kind of keep in mind as we look at the properties of real numbers, it can seem like we're studying something kind of separate and in isolation from everything else that we do. But it turns out that the properties of real numbers govern what we're allowed to do with real numbers and not. And so we actually are using properties a lot of the time when we're doing algebra or arithmetic, even if we don't necessarily realize it. So they're important for a variety of reasons. So we're going to begin with the commutative and associative properties. And so we've got, first of all, the commutative property for addition reads a plus b is equal to b plus a. For multiplication, a times b is equal to b times a. And basically what both of these say is that it doesn't matter what order you either add or multiply in. For example, 3 plus 5 is the same as 5 plus 3, both are equal to 8. And 7 times 9 and 9 times 7 are both 63. It doesn't matter what order you add or multiply in. A way to remember the commutative property's name is to think about people who commute to work or commute to school. They have to drive both directions, first to work and then home, or to school, then home. They go both ways. And addition and multiplication go both ways. So they're commutative. Associative properties for addition. If you're adding three numbers, A, B, and C, you could either add A and B first, then C, or you could add B and C first, then A. For example, if you have 4 plus 16 plus 7, that's the same as 4 plus 16 plus 7. Similarly, for multiplication, if you have three numbers A, B, and C you are multiplying, you can either multiply A and B first, then C, or B and C first, then A. So 2 times 7 is 14, times 5 will be 70, or 7 times 5 is 35, times 2 still 70. For associative properties, you can either add or multiply whichever pair you like to do first. Okay, so in this next part, we have a couple of examples. First, we'll see how we can apply the commutative property to help us simplify this expression. We have a sum of four terms, some of which are x's, some are y's. I'm going to use the commutative property to reorder the middle two terms so that we'll have 23x plus 9x plus 14y plus 15y. Okay, and that makes it a little easier because now I have the x terms nearer to each other. We'll have 32 x's and then 29 y's using the commutative property. Next, we're going to have the associative property for addition. If you look at this, you can see that one fraction is 5/8, the other one is 3/8. And so if we regroup our addition, sorry, one moment. All right, so let's try that again. So we're going to have the 7/15 in front, and then we'll add to that in parentheses 5/8 plus 3/8. Now, 5/8 plus 3/8, we're all going to recognize that is the same as 1, right? That's 8/8, and that's the same as 1. And so we can add that. 7/15 plus 1 will give us 7/15 plus 15/15, and that is 22/15. So here, using the associative property made it easier for us to add. If I had just started with a part in parentheses and added 7/15 and 5/8, we would have needed to get a common denominator for the 15 and 8, and we may not have wanted to do that. Okay, now we have -9 times 7y. We can write that as -9 times 7, and then that times y using the associative property for multiplication. That will give us -63y at the end. Okay, in the next part, we have identity properties, and so there are two, one for addition and one for multiplication, and they read as follows. For any number a plus 0 will be a, and 1 times a will be a. So these are kind of in the category of like almost common sense properties. If you have 7 plus 0, you will still have 7. If you have 1 times 7, you will still have 7. The identity properties, though, we do find use for them when we do algebra. Sometimes we add 0 to both sides in a special way. And when we're working with fractions, we frequently multiply by 1 to do things like get common denominators. And knowing that multiplying by 1 doesn't hurt anything is a valuable thing to know. Okay, related to the idea of the identity properties is the idea of the additive and multiplicative inverse. For an additive inverse, it's basically the number that you would add to a number to get 0. So if you have a number a, its opposite is minus a. For example, if you have 13, 13 plus negative 13 is 0. So negative 13 and 13 are additive inverses of one another. Similarly, a multiplicative inverse, that's the number that you would multiply by a number to get 1. So 5 times 1/5 is equal to 1. So you could say the multiplicative inverse of 5 is 1/5, and going the other direction as well, the multiplicative inverse of 1/5 is 5. Okay, similarly for addition, the additive inverse of 13 is negative 13, and the additive inverse of negative 13 is 13. So as a couple more examples, if we had the number 4/9 and we wanted its multiplicative inverse, that would be 9/4, because 4/9 times 9/4 is equal to 1. And if we wanted the additive inverse, that would be negative 4/9, because that would be the number that we'd add 4/9 to get 0. Those are the identity properties and the multiplicative and additive inverse. Okay, the next thing has to do with properties of 0. 2 are easy, and then 1 is a little less so. So if you have any number a and you multiply it by 0, you will get 0. Okay, example, if you have 5 times 0, that's going to be 0. Okay, and similarly, trickier a little bit with division, but we'll be careful. If you have any number a that's not 0, 0 divided by a will be 0. For example, 0 divided by 4 is 0. On the other hand, division by 0 is undefined. For any number a that's non-zero, a divided by 0 is undefined. Specifically, for example, 12 divided by 0 is undefined. We want to have a way to kind of keep these straight. You could think of this in terms of related multiplication facts if you want, but I find kind of a story can be helpful. So let's think this through for a second. Let's say that you have 12 cookies and 3 kids. Okay, let's just say. If you have 12 cookies and 3 kids, we know division is useful for sharing equally. So if you're going to divide the 12 cookies among the 3 kids, they're going to share them all. And so how many cookies will each kid get? They will have 4 cookies. 4 cookies per kid. Okay, and that's how division works. 12 cookies among 3 kids, you get 4 cookies per kid. And that part should make sense and be pretty straightforward. So now let's see what happens if I throw 0 in there. Let's say that I have 0 cookies to divide among the 3 kids. Okay? If you have 0 cookies to divide among the 3 kids, no cookies, how many cookies does each kid get? Well, it should be pretty clear that there's no cookies per kid, because you had none to give out, right? Okay, no cookies, split among 3 kids, nobody's getting any cookies. Okay, on the other hand, let's say that you have 3 kids. I didn't want to give you 12 kids, okay? Let's say that you have 3 kids and no cookies. 3 kids and you have, sorry, I have that upside down. Let's say that you have 3 cookies. And let's make it 12 cookies. You've been working hard. Okay, 12 cookies and no kids. Okay, if you have 12 cookies and no kids, how many cookies does each non-existent kid get? Okay, well, how do you answer a question like that? There's no cookies, no kids to give cookies to. So the fact that that gives you some hesitation, right, should be what makes it suggests to you that the answer there is undefined. Division by 0 is undefined. 0 divided by a non-zero number will give you 0. Okay, so there's several ways of remembering that. That's one of them. Otherwise, you could just memorize it if you like. Okay, so in the next part, we'll do a couple of examples where we're applying these properties to help us do some simplifications. So let's start with this one. We have negative 27a plus negative 48a plus 27a. So the first thing I'm going to do is I'll use the commutative property for addition to reorder the second and third terms. So we'll have negative 27a plus 27a plus negative 48a. Okay, and then I can actually use the associative property to say, well, let's group those first two, negative 27a and 27a. Let me use round parentheses for that. And then add in the back negative 48a. Okay, now negative 27a and 27a, you'll recognize those as additive inverses of one another. And so their sum is going to be equal to 0. So this will give you 0 plus negative 48a. And any number plus 0 is just equal to that number, right? So that just gives you negative 48a. Okay, now here's one where we get to multiply. 9/16 times 5 over 49 times 16 over 9. Here you're going to recognize that, well, let's try to put those 16 and 9s together. So I'm going to use the multiplicative commutative property to reorder the second and third factors. So we'll have that 5 over 49 in the back. Okay. So now, again, we can use the associative property for multiplication, right? 9/16 times 16 over 9, and then whatever that is, times 5 over 49. Now, the part in parentheses, those two numbers are multiplicative inverses, right? And so they're going to equal 1. So we have 1 times 5 over 49, that's just equal to 5 over 49. Okay, so you probably learned to do this multiplication with fractions where you could just cancel stuff out and you can jump over, whatever that means, jump over the 549 in the middle. These steps kind of justify that using the commutative and associative properties. Okay, the next property, and one of my personal favorites, is the distributive property. The distributive property is used a lot in algebra, and it enables us to do a couple of things. It enables us to take an expression that involves parentheses when we're multiplying something by a sum or difference and remove those parentheses or insert those parentheses later. So the first thing we want to do is look at how the property works and then see some examples. So the distributive property reads like this. Here, A and B or and C or any numbers you want. If you have the sum of two numbers, B and C, so B plus C, and that's multiplied by A, you can multiply the A times each of those two addends and then add the results. Similarly, if you have a difference of two terms, B and C, and that's multiplied by A, you can multiply the number A times B and C and then subtract. So what a way to look at this and how this works is to think about the area interpretation for multiplication. So taking a look at this big rectangle that is 6 units tall and 7 units wide, the area of the whole thing, if you remember the area of a rectangle, is equal to its length times its width, product of the two dimensions. Then if you look at this, this is 6 times 7, or 42 square units, whatever they are, square inches or whatever. So, however, the big rectangle is the sum of its two parts. The rectangle on the left has a height of 6 and a width of 2. That one is 6 times 2 or 12. The one on the right is 6 times 5, which is 30. And then 12 plus 30 is equal to 42. Sorry about that. Zoom quit on me. So let me back up for just a second. So the point here is we could think of this rectangle with height 6 and width 7 as being a sum of two parts, a 2 by 6 rectangle and a 5 by 6 rectangle. and 12 plus 30 is equal to 42. Okay, so there's that. Another way kind of to think about it is to think in terms of order of operations. If you have, let's use actual numbers for this. This one is 6 times 2 plus 5, and then this is 6 times 2 plus 6 times 5. All right, so this is the calculation we made. Okay, for the expression on the left, thinking about how order of operations works, we do the part in the parentheses first, right? We would do the addition, 2 plus 5 first, then multiply by 6. The distributive property allows you to rearrange things so that you would be doing multiplications first and additions afterwards. The right side has you go 6 times 2 and 6 times 5 and then add. So do you want to add first or do you want to multiply first? The distributive property lets you switch between the two. Okay. The other thing I had forgotten to mention was that the distributive property is the first operation or first property we've seen that has two operations in it. So far we saw like the associative property, commutative property, they were just for addition or for multiplication. You can see that the distributive property has both a multiply and an add in it, or a multiply and a subtract in it. And that's our first property that has that in it. Okay. All right, so next I wanted to see some examples. So the first are going to be arithmetic examples, and I like these because most times people find these pretty intuitive. So if you were going to multiply 3 times 8.25, of course we could do the arithmetic way of getting this done, if you like. But instead, let's try to think it through for a second. 3 times 8.25. The 8.25 part is 8 plus 2.5, right? If you were going to buy like 3 objects, flower pots or something, and they're $8.25 each, how much would it be for all 3? Well, that would be like 3 times 8 is 24. And then 3 times the 25 cents, right? So you could make that calculation in your head more easily than that vertical one I showed you. That would be 24.75, right? 24.75 by multiplying the 3 times 8 first and then the 25 cents after. Okay, now let's see if you can do this one just in your head. Okay, let's say you're going to buy 5 t-shirts or something, and they're $7.99 each. Okay, about how much is that? Well, $7.99 is basically $8, right? 5 times 8 is 40. Okay, but these aren't actually $8, right? They're a penny less. So you're going to save a penny on each of the 5 shirts. So it's $39.95. Okay, so make sure you got that before we go on. 5 times $8 would have been 40, but you're saving a penny on each. That's a nickel saved all together. So $39.95. When you did that, you were thinking 5 times 8 minus 0.01. And then that's the same as 5 times 8 minus 5 times 0.01. 5 times 8 is 40. 5 times 0.01 is 0.05. And 40 minus 0.05 is 39.95. Okay, so if you did that multiplication, 5 times 7.99, getting 39.95 in your head, you are using the distributive property without necessarily realizing it. Okay, more examples. 5 times 5 6th x, sorry, that's 6. 6 times 5 6x plus 6 times a half. Okay, here we're multiplying the number outside. That's 6 times each of the terms inside. Okay, 6 times 5 6. Let me use the associative property for multiplication there. And then 6 times a half is going to just be 3. 6 times 5 6 is going to be 5. So we'll have 5x plus 3. Okay, 100 times 0.7 plus 0.15p. We'll have 100 times 0.7 plus 100 times 0.15p. There, that 100 outside got multiplied by each term inside. Okay, now we'll finish off those multiplications. 100 times 0.7 is 70, and then 100 times 0.15p is 15p. Okay. So there's a couple of examples involving the distributive property. We have a few more to do. So let's do that. So here we have -6 times 3m plus 5. So that will be -6 times 3m and -6 times 5. This will give us -18m minus 15. Okay, here you want to be careful of the negatives on this one. We'll have -7 times 8 plus -7 times -15r. -7 times 8 is -56. And then -7 times -15, that will be positive. And then 70 plus 35, that's 105 R's. Okay, now let me pause for a second there because you may not know what it was that I just did. 7 times 15, I didn't feel like writing 15 times 7 like that. And I can't think vertically as much as I can horizontally. So I was thinking 7 times 15, that'll be 7 times 10 plus 5, using the distributive property, aren't I? 7 times 10 is 70, and 7 times 5 is 35. 70 plus 35 is 105. That's where I got that 105R from, distributive property. Okay. Out front of the next one, we just have a minus sign. We'll have minus k plus minus 13. That's minus k minus 13. Distributed the negative. On this next one, you want to be pretty careful because it's really tempting to look at that and say, okay, 9 minus 3 is 6. But remember that that 3 is multiplied by the expression in parentheses, and multiplication has to come before the subtraction. So we're going to distribute the -3 into the expression in parentheses. We'll have 9 minus 3x, and then minus 3 times 2. 9 minus 3x minus 6. And then here we can reorder our terms. There's 9 plus -3x plus -6. That's 9 plus -6 plus -3x. And 9 plus -6 is going to be 3. So we'll have 3 minus 3x. Okay, I possibly showed too many steps for you there, and a lot of people don't like to see that. If you didn't need to show that many steps, that's okay. I like to show some, especially as we're just starting out. Okay, so 2 more examples, and then we're all done. So here we have 4 times x minus 8. That will be 4x minus 4 times 8. 4 outside is getting multiplied by the each term inside. Then we'll have minus x minus 3. This will give us 4x minus 32 minus x minus 3. Okay, now here I could rewrite each of these subtractions in terms of additions of negatives and then use the commutative property just as I did before, but usually people get kind of tired of that really fast. So instead, we'll just kind of add carefully. 4x minus x, that's 3x. And then -32 minus 3 is -35. Okay, so using that one as a model, pause the video and take a minute and try this next one, and then we'll work through it together. Okay, so let's try it. So 8 times y minus 8 times 1. And then in the back, we'll have minus y minus 5. This gives us 8y minus 8 minus y minus 5. Okay, and then once again, we can reorder terms if you like, or just combine like terms. 8y minus y is going to be 7y, and then -8 minus 5 is -13. And that takes us to the end of this example and the end of this section. So basically, we have gone over a bunch of different properties of real numbers, and these basically govern the behavior of numbers as we work with them. Make sure to spend some time studying those along with their names, and let me know if you have any questions, and then have a great day.